All right, and so now at this point we are just so ready for getting into those problems where we can combine all of the known transformations together, all of those transformations we've learned from the very early lecture about the elementary transformation until now. Okay, and so you have had, believe it or not, at this point you've had all of that sufficient understanding. Now let's just put all the pieces together, and we need, you only need one last advice from me right here. So now I just need to point out a little the review over here, or just a little quick summary of what we're doing. But now, so at this point, recapping of what we've done, all of that, and so now anytime when your function, basically what I want to point out first before we heading to it is that how will we recognize can we recognize that it's time to put all of the transformations together. Okay, so let's say we have a function f of x. Okay, and so now anytime that you are asked to sketch a function that's g of x, just like that, but in the form of the function f of x, the parent function here, but contains some linear expression. Okay, and so something like this, we have seen that through our earlier discussion, that something like this is that's the function that's taking a linear expression, some function f of x that's taking a linear expression inside of that. Something like this will have all of the horizontal transformation combined. So this value here, this coefficient is responsible for horizontal. Okay, so we have for sure something like that. We will have horizontal scaling. Okay, because that's what the A here explains. Okay, and then now we have to take things a little cautiously. However, in the end, generally having this constant term right here in our linear expression, that's put inside of a function, that part is responsible for the horizontal. Now I'm not saying simply this value is how much being shifted, but at least we have some clue, something that rings a bell about we will also have some horizontal shifts. Okay, so anytime the point I'm trying to make now is that what rings a good bell for us that it's time to combine all transformations together is that anytime you recognize you're about to sketch a function in g of x where your parent function here takes a linear expression as an input. Okay, so now right there with that linear expression, we already notice that there are two transformations on the horizontal axis that must be done here, must be taken care of. And then now that's just within the horizontal transformations. So now think about it's multiplied with a coefficient in front of the function. Okay, and then add with a constant here. Okay, so now this is a complete form. So this value here as a coefficient in front of our function f is responsible for vertical, okay, a vertical scaling. And this k right here, and so I don't want to get back into too far into each of these because that will make us to go back and learn from the very elementary steps. So here I'm just making that final recap. And so now at this point, generally anytime we're seeing a function, again a function g of x that's defined as a relationship with a given parent function, and then it has that plus k constant right here, it means we're expecting some vertical shifts. Okay, those are all, that is an indication of all that, it's an indication that we need to combine all of our transformations together. Okay, and so now after pointing out this, let me now bring up that only advice. All right, so now when it comes to putting all of the transformations together, then we stick with one rule. Okay, and so also allow me to make a sort of like a chart of summarizing, a chart that points out the rule over here. It's not really summarizing it, but a chart that's pointing out the rules. So we have horizontal scaling, horizontal shifting, vertical scaling and vertical shifting. There are four in my teaching style. Anytime I'm talking about breaking it down into the transformations, the elementary transformations, I only see those. There are just four major elementary transformations. Okay, and then what matters is that we know how to put them together and then combine them all together. And so now, in a way, how I'm approaching it. Okay, in a way, how I'm approaching it, and I would like to share this with my students. Then let me sketch a chart right here. So primarily, we have to nail down all of the horizontal transformations first. All the horizontal transformations must be done fast, or a little more precisely speaking, all of the horizontal transformations must be done before any of the vertical transformations. So now, as I'm writing down this chart, I want you to understand that this chart is intended, this summary that I'm writing down is intended to be read as a summary of all the steps right here. Must be read from the left to the right. So from the left to the right, according to the order here, we're doing all of the horizontal transformations before any of the vertical transformation. All right, and allow me to use shorthand writing right here. So again, 4 elementary transformations, but we've already subcategorized them into, categorize them into 2 little categories. All of the horizontal transformations, and then all of the vertical transformations. All right, so that must be done first. Okay, and then among each of these subcategorized transformations here, just the horizontal transformation itself, there was the vertical scaling, the horizontal scaling I meant, and then the horizontal shifting. And so now we're going to do scaling. Okay, we're going to do scaling, and then after that we're going to be doing shifting. All right. And then so just like that, now for vertical transformations, same rule. We're going to be doing the vertical scaling before the vertical shifting. All right. All of the vertical scalings must be done before any of the vertical shifting. So in general, I was putting that in one convention that we're always going to do scaling before shifting, scaling before shifting. Okay, and then more as in a more general setting, we're always going to handle all of the horizontal transformations before the vertical transformations. All right, and then so now as a brief reminder, doing all of the horizontal scaling. So in a whole table of 4 steps right here, then expectedly all of the horizontal scalings must be really done fast in line. And then it comes to the horizontal transformation. That comes second step. So this is the first step, really this is the second step. And then being done with the second step, the third step and the fourth step belong to the sort of like stage 2. All right, so I should have mentioned about stage. So you can think of this as stage 1 right here. Okay, stage 1, get all of the horizontal transformations done. And then in stage 1, it's really step 1, step 2. Okay, get all the scaling done first, and then the shifting horizontally. And then we move on to stage 2. So stage 2 is where we take care of all the vertical transformations. All right, so I hope at this point I really made it clear and tear it down to all of those crystal clear detailed steps like that. And so among stage 2 right here, then we're looking at the third little step right there. So third step here is compared to any of the steps we have done before, because in the end it's just one sequence of steps. Okay, and then the fourth step here is to be the vertical shifting, bringing it up and down right there. All right, and so now allow me, in this table, I am going to put in those advices that I point out. So when we're doing horizontal scaling, then remember, the form of that is your function has to be in the f of the ax. And so in that case, just as a reminder, we're going to multiply, okay? To make it easy for us, we're going to multiply every x value by simply 1 over a. Multiply every x value by 1 over a. All right. And then when it comes to the shifting, that's primarily we gotta put our, now think about, I'm putting that in a way where the shifting comes after we have done some scaling already. So I taught any of you watching this video earlier that we want to always put the linear expression inside of the parent function here as in factor form. So now we want to display a times x minus some b value. Okay, so with this b right here being whatever value that is, but we have to express it as x subtract some b value. And so now this means we're going to add, by doing this, we're going to be, the advice here is we're going to add every x value. Add every x value, okay, by b. And then now we're done with step 2, which is the last step among stage 1. And now we're moving on to stage 2, which is getting us ready for step 3 right here. Okay, so step 3 and step 4, they belong to the stage 2 of our transformation work. All right, and so now for scaling, for vertical scaling, so you gotta understand, doing this thing after you have done and have completed all of your horizontal transformations. So in that way, now think about the next step. The vertical scaling is whatever that came out from your previous step. Whatever came out from your previous step. Okay, we're gonna multiply every y value by m, and primarily the form of the expression looks like this. Okay, and so multiply, and by staying with this guideline right here, we can also, I mean, going through a compression or a stretch or even a flip vertically, it's all going to be explained by multiplying every y value with this coefficient m right here. Okay, so now we're going to multiply every y value by the coefficient m. All right. And then the last step now, this step right here, we're indicating we're going to shift up and down. Okay, and so as an expression, it's in the form of m times f, and then we keep the linear expression inside in a factor form, and now we add k. Okay, we add with that value k right here. And so now this last step right here, we simply just going to add k, okay, to every y value. All right. And just now I noticed my way of wording this is a little awkward, so I would like to fix that. We should say we're just going to add b to every, okay, x value. Simply just it. That's making it more clear. All right, so 4 steps are here, a table with 4 columns sequentially showing out all the steps of all the sequential transformations right here. And that's get any of our transformations done, no matter how complicated our function is going to be, okay, that we are about to sketch. All right, so now I'm going to keep it here. I'm going to keep it here for now. I'm going to move to the other board, and then we're going to use that space at the other board for firing up some example. Okay. All right, so now continuing into this lecture, let's now look at example 5 right here. Okay, so we're going to start out with a given function through a graph. So let f of x be represented by the given graph. Okay, and then once we're having the graph of f of x given in hand, we are going to sketch. We're going to use that to sketch the graph of g of x. Okay, sketch the graph of g of x as a transformation of f of x. All right, so that's what we want to do. So we're going to start out having a given graph, and it's the graph of some function. And again, so very similar to earlier examples, the idea here is that we do not have to worry about what rule specifically is that. Okay, it must have had some rule. What we have here is simply the rule already represented graphically through a graph. And so we're going to look at that graph and try to sketch the graph of the function g as a transformation of f of x. Okay, and so now let me now bring up the graph. All right, so here we are. This is the graph for our current function f of x. Okay, and these are now the guiding points of this function f of x. All right, just now I put in one more point. All right, so these are now the guiding points of f of x. Okay, and let's now call this. So a little bit unlike the earlier similar examples I've done back in the earlier lectures and the earlier part of this lecture in particular. So now tentatively I will be going through part A, part B, and part C for this example 5 as well. But in each function, in each problem, I'm going to specifically introduce you to a different graph. So here this is just the graph of part A, and then we're going to graph g of x. So this is the graph right now for f of x. Okay? And then I'm gonna write down the function g of x, and then we want to sketch that graph and put that together here. But then in part B later on, f of x is gonna have a different graph, so I'm gonna show a different picture for part B and later on and the later problems. Okay, so that you have a more flexible understanding, and you will broaden out your understanding in terms of the graphs of these functions. Get yourself more familiarized with those the graphs of those other functions out there. Okay, so now just again, this is just the graph for f of x. Okay, and we're trying to sketch the graph for g of x, and I haven't even written down g of x yet. But now in part B of the example and the later problems, I'm going to keep switching to different graphs of f of x, and then I'm going to bring up the different g of x as combinations of f of x. Okay, and so now here we go. Let's get into part A. And at this point, I am moving on with this lecture, with this particular problem, completely live, meaning no plan ahead. Because I want you to understand from that, once you have caught that general advice from me that I had put on the table from the other board right there, that we can roll anywhere. We really can roll anywhere. So these functions I'm coming up with here, they came out really as from my own improvised thoughts. Okay, and then as no matter how improvised we are, we can always have a way to handle the problem. Okay, all right. So now f of x has the graph as given here. G of x. Now, how about my creativity give me f of minus 1/2 x minus 1. Okay, and then I would like, so these numbers came out from my own creativity. And then I would like to put how about a 3 right here and a minus 5. All right, and that's what I meant by I'm rolling completely live here. And so also be ready to forgive on my own mistakes for whatever, because in this particular problem I made it completely live so that you can see the ones you fluent with these skills and particularly stay with that advice, and you can start putting away notes and anything like that. We just stay with that guideline, and we get any problem done with that generality, and it works anywhere. Okay, So now, before we get further, so now I came up with that function. I want, so f of x is in that graph, okay? And then these numbers just came out from creativity of my own, okay? So think about you seeing any random problem. So now I'm gonna grab a red marker, and so now plan for yourself a little bit, plan for ourselves a little bit. So this value right here is responsible for, this is vertical, okay? This is responsible for vertical, and I don't even have to, like I said, stretch or compress, depends on how we're doing it in detail, but generally speaking, I see this as a vertical scaling. All right. This last number here will be responsible for vertical, okay, shifts. We will expect some vertical shifts. Okay, so and with this value over here, including the negative sign here, is responsible for horizontal. Okay, there's horizontal scale, and then this value right there is related. I'm not saying it's entirely responsible, and that's how I have been explaining throughout the whole time. So here, but at least it rings a bell that we will have some horizontal shifts, okay? That must be taken care of. All right, so now, but that's just a quick note. I'm writing it down, and then we're just gonna quickly erase that to get it done. And now, I just realized just now that the graph was covering this part away. Okay, so tentatively, I am expecting that there are 4 elementary transformations involved in this problem. It looks quite crazy. Okay, it looks pretty crazy. All right, so now let's get to it. All right. And so now one more glance at that table, because I do need to maximize my board space to work with. So we're gonna have one more glance at that table, and then hopefully you can feel free to pause the video or whatsoever. But have that table to copy down somewhere, and then we're gonna take a glance at that one more time, and then I'm gonna have to erase that board right there to make space for all of my work right here. Okay. So again, anytime we are combining all transformations together, there are 2 major stages. Stage 1, get all of those horizontal transformations done fast. That involves 2 steps. Step number 1, get all the scaling done fast. And this is the advice here. That advisor works anywhere. Then among stage 1, we're heading over to step 2 right here. And I call this is really step 2 of the entire sequence. Okay? Then we're gonna take care of the horizontal shift. Okay, and then the horizontal shift here, we gotta put our linear expression inside of the function in factor form. And I talked about this when I was going over the data particular stuff earlier in this lecture right here. Okay, so it's always the best practice here in my style of teaching my student getting into this stuff right here, because we're always gonna do horizontal transformations fast. So get your linear expression inside your parent's function factored out, okay? And then after we've done with all of these the horizontal transformations, then we're moving on to step 2 right here, where it's involving, stage 2, okay, where it's involving step 3 right here, being the vertical scaling, all right, and with that advice here, and then vertical shifting, all right, and then let me advise that you can put a highlight here at these value for you to see how the problem evolves as we move on through the steps. All right, and so now in that way, let's get back on the other board. All right, so now I am going to factor out that linear expression inside of my parent's function. So really g of x equals 3 times f of, okay, but now I have to use brackets to indicate that I will have 2 levels of parentheses. Okay, so now 1/2 factored out that linear coefficient there, okay, will be factored out including the sign. So now factoring out that negative 1/2, I'm going to have the following, these two terms left behind in parentheses as x plus 1. As x plus 1. Okay? As a matter of fact, I just now had a miscalculation, x plus 2 indeed. Okay? And so minus 1/2 factored out, and so consequently we ended up with x plus 2. And so this x plus 2 right here is still not satisfying to me because I want to write it in the form where it displays clearly, I mean crystal clear, that we're going to have some horizontal shifting. And so the better way of writing this, even though this is already correct, but the better way, the more precise way of writing this plus 2 as x subtract negative 2. Okay, x subtract negative 2. Now we have a clear clear bell rang up for us that, hey, we will have some horizontal shifting, and this is how much precisely being shifted. Okay, and so now we have all of that pieces of information together. All right, and then now one more time looking at the graph. Let me also put in the labels, the numerical labels of these guiding points right here. As a matter of fact, I don't really need to put in this point right here. But then I decided to put it there. So now with numerical labels, these are the points. So we have 1, 2, 3, 4, 5, and 6 points. Okay, 6 points here that define our shape of the graph. Okay, that define the shape of our graph. And now I'm going to keep it there at the corner of our board right there. Okay, so just like that, in that same approach I've been using, I'm going to construct a table, and that table will reflect the table of the summary table I just now erased right there. And you will see all of now. This is the point where all of my teaching stay connected together and being consistent with each other step by step. Okay, so now this graph right here that you're seeing. Okay, as far as the original parent function, I recognize the following points right here, guiding points. So from the left to the right, we're looking at negative 3, negative 5. That's 1 point. Okay, and then another point I'm seeing, we have a point at 0, 1. All right, and forgive me if I keep swinging back and forth between the board and the computer station in front of me here. All right, and another one I have here is 1, 1. So these are the guiding points, and I said again, the whole idea about the guiding points here, they are particularly useful for me to construct my graph right here, to apply my transformations. Okay, and now the next point I'm looking at here is going to be 5, 3. All right, and I'll have another point here, and I may have to squeeze a little bit. Okay, and I'll have another point at 8, 0. All right, and now it looks like I'm going to have to make some more space here, or indeed, let me revise my table a little bit to make it more space saving. That's supposedly 1, 3, and then here I got 5, 3. Okay, and I'll have an 8, 0, and I have one last point down here as being at 11, 3. All right, so these are all the points that I have right there. Okay, so I need to show the full screen of my board right there. Okay, so now these are the points. And so now the first step is to apply the horizontal scaling. Okay, so step 1 right here. So that means I'm looking at, so back to my function. it was the negative 1/2 here is responsible for that the horizontal scaling. And so here in this form, I'm seeing this as in my next step, I'm trying to nail down the transformation as in f of negative 1/2 x. Okay, f of negative 1/2 x. So that means this is the a value. So a equals negative 1/2. It means even further that 1 over a will equals 1 over negative 1/2, which is a negative 2 totally or finally. Okay, and so in that case, now back to that advice, when we're applying that horizontal transformation, that horizontal scaling, then we're going to multiply every x value by 1 over a, which is negative 2 here in this case. All right, every x value is multiplied by 1 over a. So now that means this first point is transformed into, so negative 3 comma negative 5 is now transformed into positive 6 comma negative 5. Y value stay the same. Okay, x value came out from negative 3 times negative 2, because this is 1 over a. All right, and so now negative 3 times negative 2 is a positive 6. The next point here, 0 comma 1, will be transformed to 0 comma 1 again. I see this 1, the y value here stays the same, because for now we didn't do anything with the y value. But the x value here looks like it stayed the same, but simply because 0 times negative 2 equals 0 again. All right, that's how I got that transform point. And then for the next point at 1 comma 3, here I am looking at this point is transformed to negative 2 comma 3. Negative 2 comma 3. And that is because, once again, y value stay the same. X value is multiplied by 1 over a, which is in final calculation, negative 2, this problem right there. And now in my next point, 5 comma 3 is transformed into negative 10 comma 3. Okay, and now I can start picking up pace a little bit already. So 8 comma 0 originally now will be transformed into minus 16 comma 0. And then here I'm looking at minus 22 comma 3. Nothing happened to the y values at all. Only the x values got multiplied. Any one of the x values here gets multiplied by minus 2. And that's how consequently I ended up with these values there. All right, but now at least this second column, aside from the column listing down all of the original guiding points on the parent's function, then this is the complete point. I mean the point of completion of our first step in all of the transformations. So horizontal scaling is now done. But that's not all we have here. We're expecting horizontal scaling and horizontal shifting. Okay, and after that I'm expecting vertical scaling and vertical shifting as well. This problem has all four the transformations being in there. Okay, and so now in my next step I'm going to create a column for f of, now I put my linear expression in factor product like this, instead of writing down the exact form like that. Okay, so now it's negative 1/2, and then multiply with x minus negative 2. All right, and then so now doing this, it means this is how much I'm going to be shifting. But then shifting or not, to physically shift a graph left to the right is not that easy. Think about that advice I've had. Add a negative 2 to every x value from the previous column. All right, so now in that case, in that way, now I'm going to add negative 2 to every x value. So that first point here is now transformed to 4 comma negative 5. Okay, because y value stayed the same. The last x value was 6. Now adding negative 2, that gives me 4. Okay, the next one here gives me negative 2 comma 1. saying that 0, 1 is transformed to negative, 1, negative 2, 1. Okay, and so y value stay the same. X value here is added to negative 2. All right, and then now let's move on to the next one. So this point at negative 2, 3 is now transformed to negative 4, 3. Again, y value stayed the same. X value here came out because the x value in the very preceding step added with negative 2. Okay, and now in the next step, and now we can start picking up pace here. In the next point right here, negative 10, 3, that point there is transformed into negative 12, 3. And the next point right here, okay, negative 16, 0 is now transformed to negative 18, 0. All right, and then the last point here that we're looking at, negative 22, 3. We're now looking at negative 24, 3. All right, but at this point we have completed the step 2 of our transformation work right there. And this is the end of stage 1. This is where we have finished all of the horizontal transformations. And so now in the later columns we're going to be moving on to the vertical transformations. Okay, or stage 2. But now within stage 2 we're going to have step 3 waiting ahead for us, and then step 4. Okay, and so now I'm going to extend my table even further. All right, so now I'm extending my table further. So now from where the function of the previous step, negative 1/2 in parentheses, x minus negative 2. Okay, and then when it comes to this one right here, then I can get back to its short form from the beginning to save myself some space right here. So how about I can write this as f of minus 1/2 x minus 1, okay, because that was the form how it was written originally, and then we already had that nailed down. So in the next step I'll just write it down in the short form right there. But now we're looking at, don't forget, here we're looking at, there's a 3 right there. We multiply with a 3 coefficient. Okay, so I would like to highlight that. Okay, I would like to highlight this. Now I would like to highlight that. All right, and now, so now in that way, doing this vertical scaling, this value here, just as a reminder about things we've learned, and it's gonna cause a vertical stretch because the absolute value of this is above 1, and it's a positive, so it's not gonna flip the graph vertically. Okay, but with so much information like that, we just want to stay on something simple. So stick with that advice. We simply just multiply every y value from the previous step by a factor of 3 right there. Okay, and so now that's how this point now 4, negative 5 is now transformed to 4, negative 15. Now again, when we switch over to stage 2, nothing happened to the x value. Okay, we only apply the transformation to the y values here when we're in stage step 3 and 4. Okay, and that's how x value here stayed the same from the previous step, but now y value is multiplied by 3 here. And that's how I ended up with 15. In the next one here, negative 2, 1 is transformed into negative 2, 3. Okay. The next point here, negative 4, 3. Now it's transformed into negative 4, 9. So once again, I have 3 here because 1 multiplied by 3. That's which gave us 3 at the end. I had this 9 here because 3, the y value, multiplied with 3 equals 9. Okay, and now we can start picking up pace again. All right, so this point at negative 12, 3 now is transformed to negative 12, 9. The next point here is negative 18, 0 because every y value is multiplied by 3. And the next point here is transformed to negative 24, 9. All right, and so now at this point, I'm done with the third step right here, completing out all of that, the vertical scaling, okay? And then seeing it as a stretch or not. Let the graph speak up once we're done. How's that? Okay? And then, so now after getting all of these guiding points at this step right here, now we're just having the last step waiting for us. Okay, so now with the last step, here it's simply 3 times f of minus 1/2 x minus 1. But then after all of that, we're going to add, we're going to have a minus 5. So minus 5 in algebra, it means we're adding negative 5. It's just the rule of algebra and the rule of number. Okay, so minus 5 means add a negative 5. That's what it is. And so in that way, minus 5, okay, and as I said earlier, it means we're adding a negative 5. So this negative 5 that I'm writing now in red ink is indicating that that's how much determining how much up and down right there. It's a negative value, and so it's going to show that we're going to push it down, push the graph downward by how far? 5 units far. Okay, but again, that sounds that it hears easy. Speaking it through the mouth is easy. Through the mouth is easy, but then getting it down and done it correctly is not. It's not that simple. So I just stay with that advice I've had right there. I'm going to add minus 5 to every y value from the preceding step right there. All right, so now from the preceding step, 4 comma negative 15, now it's transformed to 4 comma negative 20, because again, y value here previously, I'm going to add negative 5 to that. Okay, and that's how I've had that. And now for the next one here, I'm looking at minus 2 comma 3, so the transform points become minus 2 comma negative 2, again, because minus 5 plus 3 is a negative 2. Okay, and then at this point, and I just now realized the fourth column here will always be my final one after all transformations being combined together. So I should have written that in blue ink. So allow me to quickly erase this, okay, and forgive my mistake right there. And again, because I'm moving on with this lecture here, with this part of the lecture is completely live right here. Okay. All right. So this first point here is a 4 comma negative 20. All right, and then this point here came out to be minus 2 comma negative 2. All right, and then this point here came out minus 4 comma 4. And then this next point here, so every one of them here, as we are advancing, as we are proceeding, then any of the y value here is added with negative 5. See? So that's why 9 plus negative 5 gives me 4. 3 plus negative 5 gives me negative 2, and so on and so on. And so now in the next point here, I can start picking up pace a little bit. So minus 12 comma 4. Here, the next one here, I'm looking at negative 18 comma negative 5, and the last one here is minus 24 comma 4. And so these points in blue right here, they are my final point of the descendant function g of x. Okay, so again, this is g of x, right? And that is the descendant function, and descendant in the sense that it's related to the function f of x, okay, through this relationship as a transformation. All right, so now we've made the table that complete all the transformation. This is step 1, step 2, step 3, and step 4. Okay, the first two columns, they are in stage 1. The last two columns, they are stage 2. All right, and so now we're going to look at the very final one right here and put it on our graph. So at some point earlier, I had to turn off the graph so that I can maximize my board space. Let's now look at the graph in complete full screen view right there, so to have a close look at the graph, and now see how I can put in these final guiding points here. Okay, so feel free to to pause the video and take notes of these points right here, so that in case you are working together with as I'm moving on right here, then you have some reference. Okay, All right, so now with the graph. All right, and I believe I have to put this in a further zoom. And so now let's show those guiding points in blue color. All right, so these are the guiding points right here. And now I even have to change the setting on my decimals a little bit. All right. And so we've had 1, 2, 3, 4, 5, and 6 points. And right now on the graph it shows a 1, 2, 3, 4, and 5 point, and that point is almost lost right there. So I'm going to have to zoom it out even a little further right there. And now that last point here is corresponding to that very bottom point right there. Okay, and so just a little reminder here, but when we put our linear expression inside of the function f here in factor product right there, then we notice our coefficient a was a negative coefficient. So I did have the expectation that we had an expectation that we will have the graph here flipped horizontally. Okay, and so now the reason I'm mentioning that is that so now when we're looking at the primary shape of the beginning graph here, then from the left to the right it was a line going up, it's straight out, flattened out, and then coming down as a bottom part of a bow right here. Okay, so straight line, horizontal line, and then a bow, a bottom part of a bow. So in that case, now think about if we're flipping it. Think about if we're flipping it on the other side right there of the y-axis, then things will behave on the opposite way. So we will have this part here being the bow through that, and then that's a straight line, and then these are the point that's connected as a straight line right here. So this is a straight flat line, and this is a straight line slopey line right here, and it's supposedly a bottom part of a bow right there. All right, so now we are ready to make the sketch of the graph. All right, so let's have a look at that. And so now I am going to sketch. All right, so now sketching that graph. You see, so that bow is now here from the left to the right instead of being the last part like in the original parent function. And now I'm going to continue sketching further by connecting this point with that point as a line, as a flat horizontal line. All right, and then I'm connecting between that point and this point right here as a line that's dropping down, and further continue to drop it down further. And so now that completes our graph here. And so this graph here in blue now is the graph of this descendant function g of x, but it has all of that fundamental shape from its parent. So just like that. All right, and that's how we're done with part A of the example. Okay. All right, and so now let's look at part B of the example. All right. And so now I am going to write down part B. But then again, just like how I said earlier, for part B here, I am expecting a different function f of x with a different graph given. And then we're going to come up with, we're going to sketch g of x. So allow me to just quickly write it down first. So g of x here, I want it to be minus half f of all right, so g of x equals minus half f of 4x minus 4 plus 1. Okay, so now, but let me now introduce the graph of f of x. It's not the same one as we've had earlier. All right, so this is now the graph of our function f of x in part B right here of the example. Okay, so that's the graph, and I already put down a few guiding points that stays right on the grid right here. Okay, and so now let me talk a little bit about this graph. So all I need for anyone to understand is that we don't have to worry about what rule specifically gives this graph. Okay, we don't have to know what rule specifically it is for this graph. Is that an x squared, or is that x minus 5, or the x to the 10th or whatever. That's not important. We don't need to know that. But let's say this is the graph that's already represented the rule for this function f of x. Any function has to have a rule. We're just seeing it or not. Okay, but here seeing the rule of this function f of x is not important. We already had the graph representing the function, and then we already furthermore we have that set of all the guiding points. So now from that graph given here, we want to sketch the function g of x here being negative 1/2 f of 4x minus 4 plus 1. So we're going to take that graph that we're seeing here, do some transformation. That's all it needs right there. Okay, so now in order to move on successfully, again, just like that work we have done in part A, and now I'm going to start picking up pace a little bit. Okay, the common good step here is that we're going to factor out the inside that linear expression inside of our parent function. Our parent function is this graph. Okay, and so now I'm going to factor out. So f of x right here, the parent's function, this 4x minus 4, I'm going to factor out a 4. The coefficient in front of the x here is a positive 4. So factoring it out, we're going to look at x minus 1. Okay, and then that coefficient here is still there. That's how it is. And now we have some clear picture of what's going on. We have some clear expectations. Okay, we know clearly what to expect. Okay, so now allow me to turn off the graph here because I need more space here to write my work. But this value negative 1/2 will be responsible for some vertical. Okay, we just sketch down what's to be expected. So vertical scaling will happen. Okay, I am expecting vertical shift. All right, so vertical shifting. All right, and then now inside of our function, let's look at that linear expression inside of our parent function in factor form already. Then I'm expecting here we're going to have some horizontal scaling. Okay, and then here it's perfectly in that form x, subtract, so this value 1 right here is responsible for the horizontal shift. All right, so again, I'm expecting to have 4 transformations happening here. Okay, all right, so now let's move on to the other board and see how we can lay down the steps here. Okay, and again, before I show the other board, these are the guiding points again. These are the guiding points. Okay, these are the guiding points of the original parent function. All right, so now after leaving the graph on the board there for a little while enough, okay, so now you can clearly see that this now is the complete graph of all of those, this is the complete list of all of those guiding points on the original graph you have seen earlier. Okay, and I hope you had some time copying down those guiding points that I've had on the graph. Okay, and so now from that list of the guiding points, so now I'm going to start applying my first transformation step right here. Okay, so for my first transformation step, namely it is I need to do f of 4x. Okay, f of 4x. So this is my a. Okay, this is my a. So every x value must be multiplied by 1 over a. Every x value is multiplied by 1 over a. Okay, so that means the first point here is transformed into. And so after having some good experience by seeing my earlier problem right there, I am going to start picking pace a little further up. And so I am now going to multiply this minus 2, okay, with 1/4, 1 over a right here. So in that way, my point here is transformed into minus 2 over 4, which is a negative 1/2. So negative 1/2, comma, 1/4. Negative 1/2, comma 1/4. It's all due to the fact that negative 2 times the 1/4. All right. the next point here is transformed into negative 1/4, comma 1/2. Okay? Nothing was done with the y value, nothing was done with the y value. The x value here came out because negative 1 originally multiplied with 1/4. Okay, now the next point here, we're going to be looking at 0, comma 1 again, simply because 0 multiplied with 1/4 is still going to remain 0. Here I have 1/4, comma 2. All right, and so that is because of 1 multiplied with 1/4 here. That's how I got to 1/4. And then nothing, again, nothing was done with any of these y values. And now in my next step, 2, comma 4 is transformed into 1/2, comma 4. Okay, due to the reason that 2 multiplied with 1/4, 2 multiplied with 1/4 is reduced down to a 1/2, and comma 4. Nothing happened to the y value. Okay, so at this point we're done transforming from f of x to f of 4x. And now we're getting ready for the next step. So the next step we're transforming from f of 4x to f of 4 times x minus 1. All right, f of 4 times x minus 1 in parentheses is here. All right, so in that way now I see this value here, and we already had that sign, that good sign ringing up that we have a horizontal shifting. So x minus, that's what it is. So now this value 1 by itself is a positive 1. Okay, it's deciding how far we're shifting left and right, and we're shifting to the right hand side, right, by 1 unit. But then really all that is just a matter of adding 1 to every x value. Okay, all right, so now in that way allow me again to keep the pace a little bit faster here. So minus 1/2, comma 1/4 is transformed to positive 1/4, comma 1. I mean positive 1/2, comma 1/4. Okay, and that 1/2 here came out because 1 is added to negative 1/2. The next point here is transformed to positive 3/4, comma 1/2. Okay, y value stayed the same. X value came out as 3/4 because negative 1/4 plus 1. Add 1 to every x value of the very preceding column, of the very preceding step. Okay, and now here in the next one, 0, comma 1 is now transformed to 1, comma 1. Okay, and the next one down, 1/4, comma 2. Okay, 1/4, comma 2 now is transformed into 5/4, comma 2. All right, and then the last one here, 1/2, comma 4 is now transformed into 3/2, comma 4. All right, so now at this point again, and I have already sped up quite a bit because assuming that viewers at this point has been in gear and getting quite engaged into this way of going. All right, and so now we have completed our transformation points for we have successfully transformed from f of 4x to f of 4 times x minus 1. Okay, and now let's transform even further. And now from this, I'm going to transform f of 4x minus 4 to f of 4x minus 4. But then all of that here, I'm going to multiply with a negative 1/2. This is now the vertical scaling. And remember, we're doing the vertical scaling before the vertical shifting. Okay, and so now this is what's going to happen. So now when it comes to the vertical scaling, we're going to multiply every y value. And then starting here is starting with this step is the beginning of stage 2. Okay, and so nothing now, starting at this point, nothing will be done to the x values. Everything now from this point is going to be done on the y value of the preceding step. Okay, so it's a negative 1/2. Okay, so the first point here, 1/2, comma 1/4. Now it's transformed into a 1/2, but comma negative 1/8. All right, so like I said, in that same logic I was saying, nothing happened to the x value, but every y value is multiplied by negative 1/2. So 1/4 times 1/2 is a negative 1/8. Okay. The next point from the previous column right here, 3/4 comma 1/2. Now it's transforming to 3/4 comma negative 1/4. Okay, and once again, x value stayed the same, y value came out negative 1/4 because 1/2 times negative 1/2 is a negative 1/4. Okay, and let's advance. So 1 comma 1 now gives me 1 comma negative 1/2. Okay, and then once again that was because x stayed the same. 1 times negative 1/2 gives me negative 1/2 here. And now I can start skipping some of those the explanations. So 5/4 comma 2 now it's transforming into 5/4. Okay. Five-fourths comma negative 1. And then that last point, 3/2 comma 4 is now transforming into 3/2 comma negative 2. All right, so that's our point here. And this is where we have completed our transformation, transforming from f of 4x minus 4 to minus 1/2 times f of 4x minus 4. One more step to go, the vertical shifts. Okay, so now this last step awaiting for us here, I'm going to transform from this into minus 1/2 f of 4x minus 4, but I'm going to add 1. Okay, and then so this is the fourth column, and this is the fourth step among throughout all of our transformations. So now this will be our final one. So allow me to start to use a blue marker. Okay, so now with this value right here, I am going to add 1 to every y value of the very preceding step right here. So now that gives me the first point here is now transformed to 1/2 comma negative, so negative 1/8 plus 1. Okay, so I shouldn't say negative, it should be a positive 7/8. Okay, positive 7/8. 3/4 comma negative 1/4. Okay, now it's going to transformed to 3/4 comma positive 3/4. Okay, and once again that was because 1 plus negative 1/4 give me 3/4. I had this 7/8 because 1 plus negative 1/8 gives me 7/8. All right, and then the same way right here, 1 comma negative 1/2. Now negative 1/2 here added with 1 gives me 1 comma positive 1/2. Okay, and so now I can start picking up pace by skipping those explanations. Yeah. So 5/4 comma 0 here. Okay, and that is simply because see 5/4 comma negative 1 is transformed into that. Okay, and then the next one here, 3/2 comma minus 2 is transformed to 3/2 comma minus 1. These points in blue right here are going to be our final guiding points, which define the shape of our graph. Okay, so now let's have a look at the graph one more time right here. And before I switch over to the graph, feel free to pause the video and write down carefully the 4 transformation steps right here if you need to. Okay, so take an instant. And now, assuming that you already resumed with the video, okay, I'm going to hit back to the graph one more time. And so the shape of the graph here is an increasing graph from the left to the right. The graph is rising in a bent curve right here. Okay, the graph itself is rising in a bent curve. So that's the fundamental shape so I had this advice when we were looking at the earlier lecture about transformation as well. Keep in your mind the shape of the graph once you saw the parent function. So in this with this parent function, maybe it's new for the entire lecture here, but having a look at that, the shape, imagine if you close your eyes, the shape here is going to be going from one way, right, and rising up if you close your eyes and having that imagination in your eyes. Okay, it stays in there. So now whatever we do, it has to have that shape in there. So the shape here fundamentally is the kind of shape where it's going one way. Okay, it's going one way. So now, back to the graph itself in complete full screen view right here. Now these are my guiding points. Okay, these are my guiding points. All right, my guiding points are here, and then we can double check to see that they are consistent with what we have sketched down earlier. All right, and so now the graph. Think about if we draw the graph through that, then it's already forming into a bent shape and going one way. Okay, but it seems opposite. It seems opposite, vertically opposite from the one that appears in red originally. It makes sense that way. The explanation is from here. Okay, we had a vertical flip. Explain to this, but see. Sometimes when we try our best to do the actual flip, it's hard. So surprisingly, just do that trick. Then we multiply every y value with that coefficient designated here, given here, then stretch or compress or the flip vertically. It's all going to be done there. Okay, and so now it explains why the graph this time seems to be pointing down here. Okay, pointing down like that. And so now at this point, we are ready to draw the actual graph. All right, so now from the left to the right, if we really sketch the graph by hand, this is what it looks like. All right, that's the shape of our graph right there. Okay, that's the shape of our graph. Now I'm going to put it in further view so that you can see. So it still carries the fundamental shape from its parent function. It's going one way. So but now the parent function was going one way, rising from the left to the right. So this graph here is going one way, but falling from the left to the right because it was vertically flipped. Okay, and then it seems narrower. Okay, in a sense that these, if we're looking at these points here, these guiding points, they stay closer. There's horizontal space between each other. That's another way of sensing. That's another way of sensing there was a horizontal compression here. Okay, this value was having positive, the absolute value being greater than 1. So we knew that there was some horizontal compression, but graphically speaking, when we're seeing the graph, how can we sense that there was another way to double check for horizontal compression is that you see on the parent function, originally on the parent function, all of these points are space being a one square grid space apart like that. But now in this descendants function, the space is a lot more squeezed right there, and it's about right at the space of being just a 1/4 away from each other. Okay, and so that's indicating that we had a horizontal compression right there. Okay, so the graph is narrower, and it's flipped down, and then in real detail calculation, it's all being done. It's all being carried out through those guiding points right there. All right, and so for this particular the problem right here, if anyone is having in mind what is the function that has this graph in red, okay, what function has that graph? In case you know it or in case you haven't known it, eventually we will, throughout this course right here, we will get to know that. Okay, but now I only need you to see that I only need you to see that graph here as a graph, whatever function that is. But now before I'm done with this graph right here, then I can briefly mention, and then later on you will be seeing that again. But that graph generating this, the function that generates this graph right here, the function that's represented by this graph right here is that function f of x equals 2 to the x. Okay, it's a function, and well, formally speaking, we will call this function, it's an exponential function. But then right now, when we're learning this lesson, we are not required to know about exponential function, and usually learning about transformations must come before we will formally learn about exponential function, and then we will spend some good amount of time studying these kinds, these function, this kind of function right here. All right. All right, and now I am going to have an FYT for everyone before we leave this example. So, and just like how I was doing that earlier, I will give you, for this FYT right here, I will give you a completely brand new graph representing a different f of x. And then from that, you are going to make your own hand sketch on the g of x. So let me now first write down the g of x. And this is an FYT. Okay, let's do g of x equals 3 f of one half x minus 3 minus 1. All right, so that's the function that I would like you to give it a sketch. But now let me pull up the graph of the function of f of x right here, because it's not the same one that I've done in part A and part B. All right, so here we go. This is the graph of our FYT function. And again, I don't need anybody working on this problem to worry about what rule, what function has this graph representing it. Okay, and then I already had some special guiding points on that graph. Have a good look at the graph, okay, and then get that shape of the graph, stay in your mind. Okay, so it looks to me like it's a wave that's waving down and waving up and hits back down at that middle line right there. But in the end, whatever the shape, have that shape in your imagination, and then start thinking about how the transformation here will apply to that. We don't need to know what that function is. Okay, and so now go ahead and pause the video and spend some time on that. All right. Okay, so now at this point, hopefully that you have already spent some time on that. Now let me put the graph in full screen view right here. And then these are the guiding points at the right on the grid right here. Okay, so the shape of the graph in my imagination, it's just some wave right here. It's waving up, waving down. And please, if you are doing any if you're actually doing a hand sketch version, and that's what I want anyone learning from this to do. So when you're trying to draw your own hand sketch, we don't have to compete with machine to make such a perfect looking graph like this. It's just something that bent down, bent up like a cup holding water going through these points, and another cup pointing downward. It's not exactly a circle. It's not exactly a circle, but it's a dome shape enough. Okay, like I said again, it's a cup pointing up, and then there's a cup pointing down. They connect right through that point 0, 0. That's the shape that creates the wave here. Okay, but then in the end, we have all of these nicely gridded the guiding points right here. All right, so now I'm gonna put in the guiding points, and then let me first put it in further zoom. Okay, so these are the guiding points right here with the labels. All right, and I just now realized that my zooming window is not far enough to contain all points. So now all of those points are here. All right, and so now this is the graph. All right, so that is the graph of this function. That is, this graph here in blue is the graph of that function g of x equals 3 times f of 1/2 x minus 3 minus 1. All right, and you can double check for the consistency in our work there. Okay. All right, so we're now ready for heading out to the next class of problems here where we combine all transformations together. Okay, so let's look at example 6 here. All right, so we want to sketch the graph of a given function. By recognizing it as a transformation of a known function. All right, so here we are going to sketch the graph of any given function, but then we're not going to do that by constructing, the table values on paper and pencil. We're not going to throw that into a graphing calculator and hey, here you go, graph this for me. Nope, that's not how it works. Okay, we want to, before we have to do that as a hand sketch. Okay, but then before we doing that, to make it easy for our hand sketch version right here, we want to recognize the function we're about to graph as a transformation of a known function. Okay, and so this kind of problem, I believe, up to this point of our the lecture here, you have seen that often enough, and you immediately got the idea right there. Okay, it's just we allow the problem that we're sketching to become more and more challenging and more challenging, involving more transformation steps in there. Okay, and so now let me put in the first function. So part A, how about I want to sketch g of x, the graph of g of x, as 2 square root of minus 1/2 x plus 1, okay, and then minus 3. G of x equals 2 times square root of negative 1/2 x plus 1, or that negative 1/2 x plus 1 is inside the square root, in minus 3. All right, so there we go, that's our function. And unlike the earlier example, we don't have any graph of the parent function because we need to recognize the parent function. Okay, this is the more advanced form of the earlier kind of problem that we've had right here. So now looking at this problem right here, how are we going to recognize a known function to be the parent function that this came from? And so you have seen my reasoning from earlier examples that's similar to this. From right now, I'm not going to worry too much about how exactly I'm going to see g of x as a descendant of some other parent function. All I see right now, just think about if you completely rely on your own natural sense. This expression right here is inside the square root, so square root. So there's now like a light bulb coming out for us. Ideas coming out. Hey, wait a minute. We thought we knew f of x being that simple square root of x function. We knew this one. We knew this function from the list of our toolkit functions. This function was one among our toolkit functions. All right, but see, this is just too simple. This is just square root of x, whereas here square root of minus half x plus 1. Of course, they're not the same. But we can already see some similarity. That's all it drives me. That's all that has driven me into choosing this as a known function. So now I see this as I thought of this as my known function. So I know this function. I know that function. And then let me now quickly bring the graph of that function on board, okay? All right, so this is the graph of our known function. F of x equals square root of x. All right, and then I also have the guiding points there from. But so now, the next challenge here, but again, I'm going to try to break it down step by step and showing clearly with the thought process. So now, yes, we know this is the known function, but it looks way different with this current g of x that we're currently attempting to sketch. So we're going to have to make that bridge. We're going to have to see how this g of x here is going to be related with that f of x here as parents and descendants. Parents and descendants. Okay, so now here's how I'm seeing it. The rule for f of x, write on this, because tentatively we want f of x to be the parent function. So just write on this rule right here. The rule says what? For any input, the rule of f says we take the square root of the input. We take the square root of the input. Okay, so think of it this way. We take the square root of, the way how I'm saying this expression now outside from that 2 right here, the way I'm saying is I see square root of the whole minus 1/2 x plus 1. So wait a minute. If I just take the whole minus 1/2 x plus 1, this linear expression, and place it right inside of my f of x function, don't I produce? And let me now turn off this graph right here. If I'm doing this, don't I produce square root of minus 1/2 x plus 1? And now all of a sudden I realize, I'm getting closer to that overall form of this function g right here. We're getting closer. So at least now how I see is g is at least similar to this one here, in a sense that I'll just take this entire linear expression, negative 1/2 x plus 1, substitute it, okay, into the function f of x. I dump that whole expression, minus 1/2 x plus 1, into the function f of x. Plug it in, okay, and I produce this. And it looks so close to this already. Okay, just a little bit more detailed information missing right here. This function g of x outside the square root has a 2. At this point, we don't have a 2. So think about it. It just easily multiply a 2 in front of the function. And that will give us that expression that looks even closer to the expression of g of x. Okay? And then, so now I'm running out of space here a little bit. All right. And I wrote it down with little space here for a reason. So now with this current expression, it's even closer to the expression of g of x, but it's not quite there yet. So what do I realize? I'm missing a negative 3, a subtract 3 outside or after the square root operation. Think about the order of operations. From the inside out, we have to put this inside the square root. So take the square root of that first. And then multiply by 2. That's why I put in that multiplication by 2. That multiplication with 2 right there. All right, and then after we're done with the multiplication, here it comes adding or subtracting. So now subtract 3, that means here it's that. So at this point, wait a minute. This is g of x. How about, let me underline that with red color right here. This is g of x, I realize. So now I click with that, and now I realize that relationship, okay? That relationship here points out that g of x equals this 2f of negative 1/2 x plus 1 minus 3. That's the relationship between f of x and g of x. G is the descendant function as a combination of all transformations from f of x. So that's now, so I put it in a box just as a highlighting point right here, but that's not intended to be the final answer. Okay, so don't get me wrong on that. We're still going to have a long journey to advance from here. But at least this is about halfway already, being able to recognize our function g of x being the descendant of a known function. That's the relationship. Okay, now we are ready. The other work is just halfway. All right, and so now having that relationship, pinpoint, let's now advance to the other board. Okay. All right, and now again I'm showing the graph of the parent function in red right here. This parent function has a few guiding points that's quite noticeable. They are right on the grid, right? And I put the labels here. All right, so these are the label for the parent function. And so now I'm going to write down the list. When I'm back on my board, I'm going to write down the list of these guiding points right here from the parent function. All right, so now here we go. So f of x originally right, the first guiding point from the left to the right is going to be, that point is a 0, 0. The next point is 1, 1. The next point is 4, 2, and the next point here I have is a 9, 3. All right, that's a 9, 3. Okay, and then, so I nailed that down, but then I just now realized there's one little step that I forgot, so I just want to roll back a little bit. So think about, I should have done the step that I'm about to write here before sketching down this table. That function g of x that we have seen from the earlier board being related with f of x as 2 times f of negative 1/2 x plus 1 right here, okay? That function, I should have written that as 2 times f in brackets. See, I'm about to factor out this linear expression inside of my f of x. So think of this step as a step that I should have done that on the other board before I came to this board right here and get my table drawn out. Okay, sort of like you put yourself in a routine of work right there, in the routine of the steps of the work. Okay, so now factoring out that coefficient, now the coefficient here is a negative 1/2. So just factor it out, negative 1/2, and here we're looking at x, but now minus, okay, x minus 2, and then minus 3 outside of f. So this minus 3 is after we took f of this. All right, so even when I'm writing down these things, I'm following the order of operations. All right, so let's get it completed. So now once we pinpoint this, now let's put it all on the table here. Okay, so now I can just quickly, well, let me bring back the graph in a corner of my board right here so that we can double check with these guiding points to be consistent with what's on the graph right there, to make sure we didn't have any error, to have any typo right there. Okay, so now once we've had that done, the first column here, this column doesn't count, it's just the column of all the original guiding points. This first column is f of minus 1/2 x. This is where I'm about to apply the horizontal scaling. Some horizontal scaling have to come first. And so this factor of negative 1/2 is responsible for the horizontal scaling. Okay, so now at this point you have seen that often enough. I'm going to really pick up the pace here, okay? Every x value from here is going to be multiplied by 1 over a. A is negative 1/2. So 1 over a is simply just 1 over negative 1/2, okay, which is negative 2, consequently. All right, that's simple enough. And I'll erase that later when I need that space right there. But for now, let's just leave it there. Okay, so that means this first point, 0, 0, is transformed into 0, 0. Again, y value stayed the same. X value came out because 0 times negative 2. Okay, negative 2. That equals 0. Okay, the next one, 1, 1. 1, 1 is now transformed to negative 2, 1. Okay, y value stay the same. but then x value is multiplied with -2, and that's how I ended up with that -2 here. -2. Okay. The next point right here, 4, 2 is now transformed to -8, 2. Y value stayed the same, but x value came out -8 because 4 times -2. Okay, and we had that -8. All right, and so now the last one here, -18, 3. Y value stayed the same. X value came out because 9 times -2. Okay, all right, so now we're done. Well, thankfully this graph has only a few the guiding points, and those within those guiding points they are already useful enough to see the shape of the graph, so we don't have to create a lengthy list of guiding points. So it all depends on the different graphs. Okay, all right, now let's move on to the second step. We're done with step 1, okay, where we apply all of the horizontal transformations, horizontal scalings. So the next one now is to apply the transformation, the horizontal shifting. So this is equivalent to f of -1/2 times x minus 2. All right, that reflects this part of our function g right here. Okay, so now when it gets to this, x subtract is perfectly already a good sign of showing that we have a horizontal shifting. Okay, and then that value 2 right here is indicating how far to shift, left or right. So it's +2, so I'm expecting shifting to the right. But then in the end, any of that we're saying it's easier to just say add a +2 to every x value from the very preceding step here. All right, so now again, you've seen that often enough, so I'm just gonna pick up pace here. This point at 0, 0 currently now is transformed to 2, 0. Y value stay the same. X value is from 0 plus 2. 0 plus 2. Okay. The next point, -2, 1, is now transformed to 0, 1. Again, Y value stay the same because within the first 2 columns we're only working with the X values. That you will nail it down at this point when you're following along with the example. Feel free to fast forward the video if you feel like I'm a little too slow pace right here for yourself. But the idea is, I'm working with anyone from the slowest level to the highest level in the same course. People work at different pace. So this next point, -8, 2 is now transformed to -6, 2. Okay, Y value stay the same. -8 plus 2 becomes -6. Okay, and the next one here is transformed to -16, 3. Y value stay the same. -18 plus 2, the X value plus 2 produced -16. All right, so we had that point. Now all of a sudden we complete it again with the second step of the transformation, and this is the end of all of the horizontal transformations. So all within this column right here, if we had any reflection, it would be all represented in this column already. All right, and then stretch or compress is all being represented here already. We will see that through the picture when we pull up the picture. Okay, so now we're ready for stage 2. So my next step right here, and now I can erase this space because I need more space right here. I can erase what I put here on the board. All right, and I can now put this away as well. Okay, so now I'm ready for the next step here, which is doing all right, so now about 2 times f of all right, and then a -1/2 x plus 1. -1/2 x plus 1. Okay, so now from that end point of all of the horizontal transformations, now taking on to the next step, now we're going to apply this vertical scaling to that. Okay, so the only advice, so stretch, vertically stretch or vertically compressed, vertically compressed or vertically stretched, or even vertically flipped, it's all going to be represented through this advice I have given out earlier. Multiply every y value from the preceding step right here by 2, okay, by 2. So now, that's why now this point here currently at 2, 0, now it's transformed into 4, 0. I mean 2, 0, okay? So x value really stayed the same, okay? But y value looks like it stayed the same, but that was because 4 times 2, I mean 0 times 2 is a 0. Okay, the next point will tell the true story. So for the next point, 0, 1 is now transformed to 0, 2. Okay, x value stayed the same again, but y value came out being 2 because 2 times 1 equals 2. Okay, and so now let's move on to the next one. Minus 6, 2 right here. That current point is now transformed to minus 6, 4. Okay, so x value stayed the same, y value became 4 because 2 times 2. That gives me 4. Okay, now minus 16, 3 now is now transformed to minus 16, 6. Okay, so once again, x value stayed the same, 2 times 3, the y value, that's why it gave 6. All right, and so now in that way, at this point, all of a sudden, once again, I'm done with the vertical scaling. Okay, at least I have applied that vertical scaling on all of my guiding points from the preceding step like that. Okay, and so now that's taken care of. Let's now move on to the last transformation, the vertical shift. Okay, so now the operation here says a minus 3, or another way of seeing it, it's a plus. It's just the way how algebra is. Minus is also a plus, but plus a negative number. Simple enough. Okay, and so in that way, now here's what I'm seeing. Shifting it up or shifting it down, it's easy to say through the mouth. Okay, but when we get into doing that, it's not that simple. So the easiest way, we're gonna add negative 3. Add negative 3 to every y value of the most preceding step right there. All right, so now 2 times f of minus 1/2 x plus 1 in parentheses minus 3. So this step right here, what we need to do, again, add negative 3 to every y value from the preceding step, from the very preceding step. So now the first point at 2, 0, it's now transformed to 2, negative 3. All right, x value stayed the same. Y value came out negative 3 because minus 3 is added to 0. Okay, so now we are ready to pick up pace right here. That point at 0, 2 is now transformed to 0, negative 1. This point here, negative 6, 4, that's transformed to negative 6, 1. And so we can double check ourselves. 2, for this current point, 2 plus negative 3 gives me negative 1. For this point right here, the reason I had 1 here is because 4 plus negative 3, that gives positive 1. Okay, for the next point, negative 16, 6 right here, it's transformed into negative 16, 3. Okay, and that is simply because 6, the y value added with negative 3 gives me this. And now, I forgot to do this, but I should have written this to be in blue ink right there. Okay, so this is our final guiding points right here. This is g of x. So I forgot to write it in blue ink, so I just made a note right here. This last column right here really is the final guiding points for g of x. So now we are ready to put this on the graph. On the graph there together with the red parent function. Okay. So now back on the graph in full screen view right here. Okay, so let's see what will happen. All right, so now these are the guiding points in blue for our g of x function. So now I realize I need to zoom it out further to show completely all of the points right there. Okay, and I may need to, I even need to adjust the resolution on my graph right there. Okay. All right. So now these are the 4 guiding points in blue. So we can see already that it's forming into a curve shape very similar to this curve of the original parent function. Okay. But then it goes from the left to the right, it's go dropping down. So we already sensed through the picture that it has that flip, that horizontal flip through the y-axis. And that was true. And that was true because we had this negative. Okay, so this negative resulted in having a horizontal flip. Okay, and then further, later on we're gonna have some, the vertical stretch or whatever, right? That will happen, but it's all shown in a picture over here. All right, so now we can just simply double check with how these points are consistent with all of the points we calculated on the board right there. And now we are ready to make the sketch. All right, so now let's sketch the graph. Let's draw a shape through these guiding points, and when we're actually sketching it, we don't have to be perfectly pretty. Okay, it's just something that represents the shape. So the shape is a sideways parabolic shape that's pointing in the opposite way compared to the parent function. And once we got through with all the guiding points, we're done. All right, so this is now the graph of this graph here in blue is the graph for our function g of x. Okay, which is from the beginning problem. It was 2 times the square root of minus 1/2 x plus 1 minus 3. A very complicated problem. And of course, it took me some time to explain, but when you actually sitting down and doing it, it won't take as much time. Okay, not even half the amount of time I spent, but simply because I was working with it and explain my thought process like that. But once you get it clicked and written and nailed down like that, it will move on a lot faster than how I did that up here on the board. All right, so now let's look for another problem. Let's look at part B right here. All right, so for part B, why don't we look at g of x equals, and how about 2 over 1/2 x minus 1 all square, and then plus 1. It's a very complicated looking problem right there. 2 over 1/2 x minus 1 all square, and then plus 1. So the square here belongs to the fraction. The plus 1 is after the fraction. Okay. Before I'm getting the work started, I just want to point out a couple of things to notice about the function. And then still, it's just I put this problem under that same example where I see this. I want to recognize this function here as a transformation from a known function, and that was the reason why I started to give you that clue ahead of time. What I noticed here is there's a square, and there's a fraction, and there's a square. Yes, ugly thing inside the square here, but the whole square is in the denominator. There's a fraction, and there's a complete square in the denominator. Okay, plus 1. And the 1 is after the whole fraction. So in that way, now I did say it out loud. It's a fraction with a complete square in the denominator. Yes, admittedly there's a 2 here, but at least this is what reminds me, seeing a square, a complete square, and only that complete square in the denominator. The following function is reminded in my mind right here, in my imagination. Think about that. 1 over x squared. It has a complete square in the denominator, and it's a fraction, And I now tell you, we know this one because it's one among our toolkit functions. We have seen that before. We have seen the graph of that before. That's why now we can legally say this function is known. Okay? I'm not saying that we have made it all clear how this known function is. I mean, I didn't say that I pointed out how this function g is a descendant of that yet. Okay? We have not recognized that, and that's where I'm about now to show you the steps how we recognize that. But as far as a clue and a tip to recognize, you see the perfect square in the denominator, there's fraction and there's a complete square in the denominator. I think of that. It's just something that trigger our thinking, our memory. That trigger point is here. Fraction and there's a square. That's the trigger point right there. And the square here is like I'm talking about a whole square. Okay? Not a square as a term in the denominator. Okay? So now I can just call this, it's my known function. Well, because we already knew it. Simple, just that. But how is that going to be related with this function? We're working our way up, okay, to point it out. All right, so now here's how I'm seeing it. Okay, now putting the two functions here side by side, okay, and I highly recommend anytime we're doing this, think about working from the inside out, Okay, the rule for f simply says for every input on any input, we take 1 divided by the square of the input. 1 divided by the square of the input. 1 divided by the square of the input. So think about, what if we put the 1/2 x minus 1? I mean, how do I even recognize to put 1/2 x minus 1 into my f right here? Simply because here, instead of seeing x squared in the denominator, like in that, simple reciprocal squared, I see a square in the denominator, completely square. But then putting it side by side, it looks like it's not just that square. It's going to be a square with something inside. Something inside of that square. I take the whole something inside there. Think about it. Take the whole something inside there and dump that into as the input into our function f of x. Now let's see what we have created. We created 1 over 1/2 x minus 1 all square. Now we realize, oh, we actually have gotten ourselves this form right here closer to the actual g of x function. Now I realize that it's this portion right here, simply just f of 1/2 x minus 1. At least that's what my thought process is, and I'm trying to present that to anyone learning this in this video lesson. All right. But now we're still not quite there yet, in a sense that this function here still looks quite different. It's a 2 here in g, it's not a 1 here. The rule of algebra. 2 over that means, well, just a little explanation. 2 over that means it's a 2 times 1 over 1/2 x minus 1 all squared. It's just a simple mathematical understanding. So 2 over that, you can always, you have your choice to rewrite it as, to re-express that as a 2 times 1 over that perfect square right there. And so now it's another bingo point for us right here. I now just realize this expression here really is 2 times of our f of this linear expression. So it's 2 times of our linear expression there. So now I'm even closer. Okay? Because 2 times all that really is 2 over that whole square if we put that into one fraction. So what about that plus 1? Simple. Plus 1. Okay? If we added 1 after taking that linear expression into f, and so once again, order of operation. We put that input, we dump that input, that linear input, the whole thing into the function f. That's the first thing. Then we multiply that function's output by 2. Order of operation. Multiplication comes before adding and subtracting. And then we add 1 to that. And adding 1 to this, we produce 2 times all that there plus 1. Okay, so now we realize, hey, wait a minute. So that means in this way how I'm seeing it. That means I have recognized that g of x is related with f of x as 2 times f of 1/2 x minus 1. Okay, that's how I see g is related with f, 1/2 x minus 1 plus 1. That's what I'm seeing. All right, and so now we are ready for getting that graph sketch. But now before anything else, I'll put the graph of f of x, this known function, on the screen. All right, so now this is our graph for f of x equals 1 over x squared. Okay, and I have put here the guiding points for that. Now, unfortunately, for this graph right here in particular, the best I can do in terms of the guiding points or these points right here, because really exactly on the grid, there's pretty much just this one point right here. The rest of them are quite pretty off the grid right there, but they're off the grid in the way that's still quite computable. Okay, so say for example, -2 is at 0.25 for the y value, which is 1/4. And then at the negative 0.5 for x right here, then we have a height being 4. Okay, and so on and so on. So we have all of these points right here with the numerical label given here. All right, and so now after seeing the graph, allow me to spend some time erasing this board right here that I've worked from with the earlier problem. And so again, before I'm constructing that table, we will be constructing the table, but then our g, yes, at this point, g of x is known as 2 times f of 1/2 x minus 1, and then plus 1. So to better assist us, and that's the way, in this style of how I'm approaching it, then let's factor out that 1/2 coefficient of that linear expression inside our parent's function. Okay, so there's a 1/2, and then there's an x minus 2 here actually, okay, and plus 1. So putting our linear expression inside the function here is extremely useful, and that's actually the style that I want to lead my students in, even though there are other ways of seeing it, but I want to save, I mean, you might want to look at that outside of my lecture. Okay, so that's how I'm putting it. So this is responsible for vertical scaling, vertical shifts, horizontal scaling, and horizontal shifts right there. All right, so now keeping that in mind, so that's how I'm seeing it. Okay, so now allow me to erase this line right here because I need more space to draw my table that lists all of the guiding points. It's not table of values to construct the graph from scratch. Okay, all right, so now, so here f of x. All right, so the first point I'm seeing on my graph that's currently showing here, -2, 0.25. All right, or a 1/4. I actually highly recommend using fraction. Okay, get comfortable with fraction. And then we're looking at -1, 1. That's another guiding point that defines the shape. And then I'm looking at -1/2, 2, 4. Okay, and then I have another point here being +1/2, 4. Okay, I have another point here at, and it looks like at this point I'm going to have to turn off my graph right here because otherwise it's interfering with my writing board right here. Okay, so now I'm having another point here is being at 1, 1, and here we're having 2, +1/4. So all of the y values are positive. Okay, and we have 6 guiding points. Okay, good enough. So now let's get the transformation tackled down. So the first step is to take care of the horizontal scaling, which is, creating that table where we transform from f of x to f of 1/2 x. All right, so now it's a matter of putting all of the details in there. It's a positive a in this case right here, and a is a 1/2. So again, as a reminder, if a is a 1/2, okay, then we're gonna think about 1 over a here as being a 1 over 1/2, which is equals 2. So now you have done this often enough. So now I'm gonna really pick up the pace here. -2 comma 1/4. Y value stays the same, but x value here is multiplied with 1 over a, which is positive 2. So positive 2 times -2 here gives me a -4. Okay, because we multiply every x value by 1 over a. All right, so for the next one, -1 comma 1 is now transformed to -2 comma 1. Nothing happened to the y value. X value became -2 because -1 times 2. All right, and then this point at -1/2 comma 4 is now transformed into -1 comma 4. Y value stays the same. -1/2 times 2 produce for me -1. All right, and then the next one here that we're looking at, -1/2 comma 4 is now transformed to +1 comma 4. Okay, because x value multiplied with 2 gives me +1. Y value stay the same, producing 4 for me. And now the next one here, 1 comma 1 becomes a 2 comma 1, and just like that, 2 comma 1/4 becomes is transformed into 4 comma 1/4. All right. Now we have completed our first transformation at least on these guiding points originally. And now we're ready for the second step. So second step is still part of the stage 1. We're taking care of all of the horizontal transformations first. All right, so now for the second step right here, I'm going to transform from f of 1/2 x to f of, now it's better to write in factor form here. Okay, so that's why I'm writing that as f of, now 1/2 times x minus 2. All right. X minus rings a good bell about it's going to be a horizontal shift. Okay, and then this 2 right here now being a positive, because we're subtracting a positive 2, it's indicating how far we're shifting. And then particularly here we're adding a positive 2 to every x value. We add positive 2 to every x value. Okay, we add positive 2 because this subtraction sign here is just a sign that rings a bell about we're having a horizontal shift. Okay, but now the value that we're going to add to every x value is 2. Okay, so now let's get it done. First point is transformed into -2 comma 1/4. Y value stay the same. X value came out -2 because -4 plus 2. Okay, next point, -2 comma 1 is now transformed into 0 comma 1. Y value stay the same. X value came out 0 because -2 plus 2. Okay, next one. Now I'm having -1 comma 4. Now it's going to be transformed into +1 comma 4. Y value stay the same. X value came out 1 because -1 plus 2. That's 1. Okay, and now we can start. I can start moving on without much explanation. 1 comma 4 is transformed into 3 comma 4. Okay, 2 comma 1 is now transformed to 4 comma 1, and then 4 comma 1/4 right there is now transformed into 6 comma 1/4. Now we have completed our step 2 of the transformations. Okay, and this is the end of stage 1. This is the end of all of the horizontal transformations. all of the horizontal transformations, including horizontal scalings and then horizontal shifting. And now we're advancing over to vertical transformations. Okay, stage 2. So now I've kept this here long enough, so allow me to start clearing out some of those minor stuff like that. All right, so now I'm advancing to the next step here, where we're transforming from f of 1/2 x minus 1 like that. I mean, this is in factor form, but f of 1/2 x minus 1. This is the original expression where the problem came from. But now I'm going to transform from that to 2 times f of 1/2 x minus 1. All right. And so now when we're getting into this, it's a coefficient multiply in front of the function. So we're going to multiply. Now that advice I've had earlier, now it's still kicking. Okay? We're going to multiply every y value from the very preceding step by the factor of 2. Okay? So now this point, and starting with this column, starting at this step, everything is done on the y value. Okay? On the y values only. So now negative 2 comma 1/4. That point there is now transformed into negative 2 comma 1/2. Okay. X value stayed the same. Y value here became 1/2 because of 1/4 times 2. That gives me a 1/2. Okay. And now I'm looking at the next point right here, 0 comma 1. It's now transformed to 0 comma 2. Again, x value in this step right here, x value stayed the same. Y value is multiplied by that factor of 2 right there. All right, and then in the next one, 1 comma 4 is transformed to 1 comma 8. 1 comma 8. Okay, because the x value stayed the same, but y value came out as 4 times 2. That's 8. Okay, and then the next one here, 3 comma 4 is now transformed to 3 comma 8. Okay, and once again, same rule. X value stayed the same, but y value came out as 4 times 2. 4 times 2, and that's why we came out to 8 here. All right, and then now I can start working without too much explanations now. So 4 comma 1 is transforming to 4 comma 2. 6 comma 1/4 is now transforming to 6 comma 1/2. Okay. Well, you can always double check your calculation. 1/2 is 2 times of 1/4. All right, but now we're done with step 3. And you can see that the work keeps getting faster and faster as we have become fluent with these skills. And it's always a rule of thumb. These 4 steps stay in that fixed order. All right, these 4 steps are represented by these columns right here, stay in that fixed order. Okay, and so now I'm going to get into the last step. So this is now we're going to transform from 2 times f of 1/2 x minus 1 into 2 times f of 1/2 x minus 1, but then plus 1. Okay, plus 1. That means now I'm going to, as this last step, I'm simply going to add 1 to every y value. Add 1 to every y value of the preceding step like that. Now we're so ready for that. Okay, so let's, so here we go. Now I'm going to use blue ink, okay, for this, because this is the 4th column, and just like that, permanently, any 4th column, any 4th step is the final answer. Okay, is the final guiding points and the final guiding points. So now minus 2 comma 1/2 is now transformed into minus 2 comma 3/2. Okay, so x value stayed the same. Y value came out 3/2 because 1/2 plus 1 equals 3/2. Okay, and now, so now let's advance. 0 comma 2 is now transformed to 0 comma 3. Okay, x value stayed the same. Y value came out as 2 plus 1. All right, the next one here, 1 comma 8 came out, is transformed into 1 comma 9. Okay, 1 comma 9. All right, x value stayed the same. Y value came out because as 8 plus 1. And now for the next point at 3 comma 8, that's gonna be transformed into 3 comma 9. And once again, x value stayed the same. Okay, y value came out as 8 plus 1. That's how we got 9 here. All right, and for the last two, I'll just simply work on that without much explanations. So 4 comma 2 now is transformed to 4 comma 3. Okay, 6 comma 1/2 is now transforming to 6 comma 3/2. All right, and now we have completed our last transformation step. Okay, there have always been only 4 major steps. Okay, so the last column is always the column where we finish with our work. Okay, so let's now get it done. Let's now put these points in blue color on the graph. Okay, and so now this is our graph. Okay. All right, so now these are my final guiding points. Okay, and I really need to put it in far zoom right there to display enough of these 6 points. Okay, so now I've had 6 points here. Okay, so now with these guiding points, and let me also put in their labels. So now with these labels on the guiding points, we can just take a moment to double check with the consistency on them. All right, and now we can go ahead and put in the sketch. All right, so this is what the graph looks like. All right, and that's what the graph of g of x looks like. Okay, so this time we did not have any flip. Okay, both on the vertical axis, on the horizontal axis and on the vertical axis, we did not have any flip. Okay, but then whatever having flips or no flips, it's all going to be explained by doing these multiplying each x value by 1 over a. Okay, and then multiply each y value by the value in front of the function, the coefficient in front of the function. Okay, and then it will come out. And now one more thing I would like to point out about this particular graph right here is that now from the original parent function 1 over x squared, when I was talking specifically about the toolkit functions, then I was explaining earlier that this function here, f of x equals 1 over x squared, has a vertical asymptote at x equals 0 over here. Okay, or it's the y-axis itself being the vertical asymptote, or as equation x equals 0. And so now once again, let me put back the graph of the g of x. So the graph of g of x, it's being shifted away. Okay, so now you can see that it's shifted right here. It's being scaled and it's being shifted. So now that that vertical asymptote is right here at x equals 2 right there. Okay, and so that shifting here is consistent with the fact that we're having, I erased that here, but it was 1/2 times in parentheses x minus 2, and so that's why this graph right here, in blue has that it has that vertical asymptote at x equals 2 right there. Okay. All right. I just quickly use my favorite graphing device right there to put in that vertical asymptote for this current function right there. All right. And so that's how it's indicating it's being shifted away, and we can use that to check. And then now hiding away the vertical asymptote, you can also see that, originally on the parent function, all of these points right here from whatever it is, the space between these 2 points was 1 grid space apart. Between these 2 points, it's half a grid space apart. But now when it comes to the blue version, it's going to be double the amount of space between the 2 consecutive points. Okay, and that is explained because we had that factor right here that's horizontally stretched out. Okay, so it's 1/2 here, but it's gonna stretch out by a factor of 2. Okay, and so but see, if we try to keep track of all of that transformation information in our mind, it's gonna be very confusing. Okay, and easy to lose track. So just use this table over here. Okay, and it keep track of every single step, and we're gonna move on, crystal clear with the steps. All right. And so now, before I'm completely done with this example over here, then let's look at an FYT for everyone to have an opportunity to try the problem on your own right there. Okay, and so all right, so for this FYT right here, now, and being an FYT, I am not going to show my thought process any longer. I want viewers or students of mine who are learning from this lesson to take your own steps, and I believe I have delivered enough examples. So as an FYT here, okay, I want you to sketch g of x to be, how about 1/2 3x minus 3 all square minus 2. All right, so go ahead and spend your time sketching this function g of x. Quite complicated looking function, but now before you sketch that by hand, recognize this as a transformation or a sequence of transformations, okay, from a known function, Okay, so go ahead and pause the video. All right, and then work on that. And when you resume the video, I will be showing the known function, at least in my own thoughts right there. And then we're gonna sketch that together. All right, so that known function, I would see that known function here is f of x is the x squared. Okay, and then here I don't think I need to point out my thought process of how I came up with that. Okay, but then once we found out with that, I see that this function g of x here is related to f of x as this is a 1/2 f of 3x minus 3 minus 2. All right, and then from this, it's better that we factor it out. 1/2 times f of 3 times x minus 1. Okay, so it has all that information for us. And then, so I'm not going to go through the process of plotting the points and all that. Let's just now look at the graph. And so this is now the graph for our known function, f of x equals x squared. Right. And this is the set of all the guiding points. So f of x has those 5 guiding points here, and these are the 5 guiding points in blue. Once you're done, you can double check for consistency. Okay, and then let me quickly put the labels in. Right, and now let's sketch the graph. Okay, so now the graph, one sketch through these points, it's going to look just like that. Okay.